The unit circle is a special type of circle. The unit circle is defined by the equation x squared plus y squared equals 1, meaning it has a center of 0, 0 and a radius of 1. So here's my center. This is essentially my radius of 1, so this is the point 1, 0. Up top here, 0, 1, negative 1, 0, and 0, negative 1. So if I pick any point on the unit circle and I draw my hypotenuse of my triangle, it has a radius of 1. And then I could draw my triangle like we've been doing. This distance here is my x distance. And this distance here is my y distance. So one leg of the triangle is x, one leg of the triangle is y, and your hypotenuse is 1. My angle is always at the origin. So if I find sine of theta, that's opposite over hypotenuse. Here's my opposite. Here's my hypotenuse. Opposite is y, hypotenuse is 1, which is really just y. So the sine of theta is y. If I do the same process with cosine theta is adjacent over hypotenuse. Here's my adjacent. My hypotenuse is 1, so it's just x. So x is cosine theta. So if I am on the unit circle, and only if I'm on the unit circle, any point x comma y is really cosine theta comma sine theta. Let's take a look at a practice problem. The terminal side of theta, an angle in standard position, intersects the unit circle. So as soon as I know unit circle, I know that it's cosine theta comma sine theta. At P, negative 1/3 comma negative radical 8 over 3. What is the value of secant theta? So secant theta, remember, is your reciprocal of cosine. Cosine is x, so this is cosine. So cosine theta is equal to negative 1/3. So to find the reciprocal, all I'm going to do is flip it. So the secant of theta is equal to negative 3 over 1, or negative 3. But remember, I can only do this because they told me I was on the unit circle. So we talked about sine and cosine, but we didn't talk about tangent. So P is the point x comma y where the terminal ray intersects the unit circle, okay? So here's my point P, x comma y. My unit circle, my radius is 1. I know that this is x and this is y. Sine and cosine in terms of x and y, we just did. We said that sine theta is equal to y over 1, or y, and cosine theta is equal to x over 1, or just x. So now I want to talk about tangent. Tangent is opposite over adjacent. So remember, this is my opposite, this is my adjacent, and this is my hypotenuse. So opposite is y, adjacent is x. So tangent of theta is equal to y over x. But I already know how y and x are defined in terms of sine and cosine. So tangent of theta is equal to y over x. But y is equal to sine theta and x is equal to cosine theta. So therefore, tangent of theta is equal to sine theta over cosine theta. So we have two ways to define tangent. We can define it on the unit circle as y over x, or we can define it in terms of the other trig functions as sine over cosine. Now, if you look at the definition that's here, it says, in terms of sine and cosine, tangent is defined as tan theta equals sine theta over cosine theta, which we just said, but now there's this stipulation. It says for cosine theta does not equal 0. Why do I need to do that? Well, cosine theta is in the denominator of tangent. And we should remember back from our previous units or even back from other math courses that you cannot divide by 0. Because it makes the fraction undefined. So therefore, since cosine would be equal to 0, it would make tangent undefined. It would make my overall fraction undefined. So if we look at the unit circle, we want to identify 5 values of theta that will cause tan theta to be undefined. So tangent theta is going to be undefined when cosine theta equals 0. And remember, on the unit circle, cosine theta is x. So whenever x equals 0, it's going to be undefined. So that would be here and here. So theta equals 90 degrees or theta equals 270 degrees. But I want 5 values. So you can't forget about your coterminal angles. Your unit circle here is labeled with all your positives. What if I went in this direction? This would be negative 90, negative 180, negative 270, negative 360, which means that negative 90 and negative 270 are also where tangent would be undefined. And I want to do one more, so I'll do coterminal on the positive side. If I have 360 and I continue moving around the circle and I hit back up at this 90-degree spot up here, that would be 450 degrees. So we'll talk about how to check these on your calculator, but if your calculator is in degree mode and you type in tangent of 90, you'll get an error. If you type in tangent of negative 270, you'll get an error. Okay, so these are 5 examples. There are really infinitely many because it continues around the circle with all of the coterminal angles over and over and over again.